Right, someone is in again. Manasi, good morning. Manasi, are you there?
Yes, sir, I'm there.
The time of the class is 9:50.
Sir, due to some network issue, I guess it got delayed.
Yeah, that's the common issue nowadays people are getting. Okay. Yeah.
Yes, sir.
Yeah, we'll be starting the ozone. Actually, ozone is for your long question. You will get a long question in IPE. So, O3 is the ozone. So, we have to see the preparations and properties of it. Okay. So, ozone happens to be a, it's an isomer of, yeah, it's an isomer of oxygen. So, it is nothing but oxygen ka isomer hai. So, where do you find this ozone? Any idea in the atmosphere which layer it has got? It happens to be in the stratosphere. Stratosphere contains this ozone layer, and this ozone layer filters filters ultraviolet rays from the sun from the sun, so which gives us the major support to the living organisms on the earth from the UV rays. So we people are protected by this ozone, protected by this ozone layer from UV rays. If UV rays are not present in this stratosphere, the UV rays so directly fall onto the earth, and it may cause some diseases on human beings, even it may cause some diseases on the living plants, green plants, and which may create atmospheric or pollution. So imbalance can be created. So that's why it's very helpful us to support our lives. So we have to see the preparation of it. Simple preparation, right? There is only one preparation. So oxygen gas. So how do we prepare this? We prepare it. We will prepare it by using preparations. There is only one preparation. So that preparation is oxygen gas when subjected to silent electric discharge. Yeah, this is the equilibrium. We will obtain O3 gas, right? So if I balance the reaction, 3 moles of O2 gives you 2 moles of O3. So this reaction, the forward reaction may we have to use silent electric discharge, right? So because the forward reaction is an endothermic reaction, that's why energy is required, and we will get ozone. So what will happen here? You have to subject the oxygen into silent electric discharge, and 10% of oxygen will be converted into O3. So this is the preparation. We don't have diagram and all that. It used to have in previous book. Nowadays there is no diagram for this. सिंपल क्वेश्चन है, देख लीजिए, आपको समझ में आ गया प्रिपरेशन कैसे करना है ओजोन का प्रिपरेशन. So this is how we prepare the ozone, right? So once we prepare the ozone, so this ozone will be staying with the oxygen. That's why the oxygen is called ozonized. ozonized oxygen. We call it as ozonized oxygen. So this is how we can prepare it from this. Okay, right. So next we'll see these preparations here, ozone ka preparation. Can you see my NCRT? Can you see my NCRT? So ozone preparation. Ozone is allotropic form of oxygen. It is too reactive to remain for a long term in atmosphere at sea level. At the height about 20 kilometers, that is the stratosphere, it is formed from the atmospheric oxygen in presence of sunlight. So this ozone layer protects the earth's surface from the excessive concentration of ultraviolet radiations. So this is the introduction. Next one, preparation देख लीजिए. When slow and dry stream of oxygen is passed through a silent electric discharge, so the conversion of oxygen into ozone about 10% occurs. The product is known as ozonized oxygen. So 3 moles of O2 gives you 2 moles of O2. So the energy required for this reaction is plus 42 kilojoules for forward reaction. This reaction happens at 298 Kelvin. Right? So do you understand here he forgot to put the equilibrium sign, but it's okay, it's a preparation of it, right? So that's why you can see this one. This is the reaction. Since the formation of ozone from oxygen is an endothermic process, it is necessary to use silent electric discharge in its preparation to prevent the decomposition of ozone to backwards. आप इस रिएक्शन का इक्विलिब्रियम कांस्टेंट लिखकर you can also apply ये O2 है ना, so O2 gives you O3. So this is 3 moles, this is 2 moles. सो आप ली शार्टलियर प्रिंसिपल भी आप इसको अप्लाई कर सकते हो. हाई प्रेशर होना है या लो प्रेशर होना है देख लीजिए, तो इसको आप अप्लाई कर सकते हो, बट दैट इज आउट ऑफ कॉन्टेक्स्ट. सो व्हाट वी डू इज हियर, सो विल टॉक अबाउट दीज थिंग्स. राइट, इफ कॉन्सेंट्रेशंस if concentration of ozone is greater than 10% are required, the battery of ozonizers can be used. Pure ozone boils, condenses and surroundings of liquid by oxygen. So these are some properties. We'll see the physical properties. Pure ozone is a pale blue colored gas and dark blue colored liquid. Both are blue, but violet black solid. Ozone has a characteristic smell and in small concentrations it is harmless. However, if high concentration raises about 10 parts per million, breathing becomes uncomfortable, resulting headache and nausea. Ozone is thermodynamically unstable with respect to the oxygen, since decomposition into oxygen results in liberation of heat, because forward reaction is an endothermic reaction, backward reaction is an exothermic reaction. All exothermic reactions are spontaneous. So, and increase in entropy. So these two effects reinforce each other, resulting large negative Gibbs energy change for its conversion into ozone. It is not really surprising, therefore, high concentration of ozone can be dangerously explosive. That's why ozone is prohibited to store. Due to ease of which it liberates oxygen and the nascent oxygen, so it acts as a powerful oxidizing agent. This point should be noted. Ozone is a powerful oxidizing agent. Ozone is a powerful oxidizing agent due to this reaction. So what's happening here? So O3 gives you O2 plus one nascent oxygen is formed. This nascent oxygen is strong oxidizing agent. किसी से भी ये react करके इनका oxide बनाएगा. That's why the nascent oxygen is produced by ozone. Therefore, ozone is said to be strong oxidizing agent. इसका by और एक भी है देख लीजिए ना आपने H2O2. H2O2 can be an oxidizing agent, can be a reducing agent. दोनों एक तरफ ही होता है, लेकिन this is only oxidizing agent, it cannot be a reducing agent. H2O2 can be an oxidizing as well as reducing agent, right? So we got two reactions here, PBS वाले and iodine वाले reactions दो दिया हुआ है. So we will do these reactions. Someone is knocking our door. We'll see who is that. Brunda, what is the time of class and what time are you in? Sai Brunda. Tejasri, what is the time of the class?
Sir, I was having network issue, that's why it became late.
Wow. Very good. No problem.
Sir, really, sir, last class I attended full day, sir.
అవునా ఓకే నో ప్రాబ్లం అమ్మా. నెట్వర్క్ ఇష్యూ వస్తే మన చేతిలో లేదు కదా, ఏం చేస్తాం. బట్ డోంట్ మేక్ మిస్టేక్ ఫ్రమ్ యువర్ సైడ్. యూ షుడ్ ట్రై టు కమ్ ఆన్ టైమ్ బికాస్ ఇట్ డిస్టర్బ్స్. ఐ హ్యావ్ టు స్టాప్ షేరింగ్ ద క్లాస్ అండ్ ఐ హ్యావ్ టు let inside the class.
Okay, sir.
Okay, so we'll see the reactions of it. The first reaction, ozone, you see this ozone converts itself into O2 and forms a nascent oxygen. This nascent oxygen is newly born nascent oxygen. Nascent oxygen is very reactive oxidizing agent. Reacts with PBS. PBS plus this nascent oxygen used from here reacts with each other and PBS is converted to PbSO4. PbSO4. So this reaction is the final reaction. Let us balance the reaction here. You have 4 oxygens, you need 4 nascent oxygens, correct? So we have got, so it should be 4 here. If it is 4, we need 4 here, so we need take 4 here and 4. So if I add these two reactions, I'll get the final reaction here. What will happen? 4 oxygens get cancelled. So we will get PbS plus 4 moles of O3 gives you PbSO4 plus 4 moles of O2. So this is the first reaction. You don't have to write all these, just you have to write only this one for our understanding. I wrote this one. Next one, the same reaction, O3 is converted to O2 plus nascent oxygen and potassium iodide reacts with this oxygen and water and converts itself into iodine gas is released forming KOH. तो इसको भी we try to balance it. तो इसको भी balance कर लेंगे. How can we balance this? Can you help me here? 2 moles of potassium, 2 moles of KOH. Hydrogens are 2, oxygens are 2. Is it balanced? Yes, balanced. So we'll cancel out these oxygens here, nascent oxygens, then I'll write the final reaction. 2 moles of Ki plus O3 plus gives us this one, right? Oh no, we have water too. Plus H2O, so gives us iodine gas plus KOH and oxygen gas is released. So these are the two reactions mentioned for ozone. There are many reactions related to this. The so formed iodine reacts with Na2S2O3 sodium thiosulfate to form sodium tetrathione Na2S4O6 plus NaI is formed. So this sodium tetrathionate is sodium thiosulfate. Ikkada nunchi we use the sodium sulfate to estimate the iodine, right? So sodium tetrathionate reaction is also used. So these two reactions you should remember for this ozone. So here are the two reactions you can check here. PbS solid reacts with 4 moles of O3 gives us PbSO4 leaving 4 moles of oxygen. So 2 moles of Ki, so he has taken only, he wrote in the ionic form. H2O plus O3 gives us 2OH plus I2 plus OH. Okay, and there is one more reaction here. Since it's a oxidizing agent, so O3 gives us O2 plus nascent oxygen, and nitric oxide reacts with this nascent oxygen to give nitrogen dioxide. If you add these two reactions, so we will end up with nitric oxide plus O3, so gives us NO2 plus O2, right? So this is the reaction. So 3 reactions are mentioned here, but some test values also given here. Just will go through this. When ozone reacts with an excess potassium iodide solution buffered with borate buffer of pH 9.2, the iodine gas is liberated. This iodine gas is liberated, which can be treated against standard solution of sodium thiosulfate. This quantitative method is estimation of oxygen. That is what the reaction given there. Just I gave you the reaction, that is I2 reacts with sodium thiosulfate Na2S2O3, so which gives us sodium tetrathionate Na2S4O6 plus sodium iodide. So this is used to estimate the ozone. Experiments have shown that the nitrogen oxide, particularly nitric oxide, combine very rapidly with ozone, and there is thus the possibility that nitrogen oxides emitted from the exhaust system of supersonic jet aeroplanes might be slowly depleting the concentration of ozone layer in the upper atmosphere, right? So here is another point related to our atmosphere. So what are the responsible for the ozone depletion? This depletion के लिए what are the reasons? Supersonic jet aeroplanes are responsible for this, right? So इनमें से जो exhaust बाहर आ रहा है, so that is containing this nitric oxide, and nitric oxide when reacts with ozone we will get nitrogen dioxide and oxygen, and what do you get here? The depletion of the ozone happens, so which will deplete the ozone. The another threat to this ozone layer is probably posed by use of free chlorofluorocarbons are known as freons. So this is alkane. ये alkane के पास आपको chlorines, fluorines, if I got connected to this one, this is chlorofluorohydrocarbon, which is known as freon, which are used in aerosol sprays. Aerosol sprays are what? डिओड्रेंट्स, व्हाट वी यूज़, डिओड्रेंट्स यूज़ करते हैं ना, वो डिओड्रेंट्स में एरोसॉल्स होता है, एंड रिफ्रिजरेंट्स. सो दीज आर आल्सो responsible. There are 3 points mentioned about the ozone depletion. So exhaust of supersonic aeroplanes, second one is freons, and the third one is refrigerators. So these 4 items will create the ozone depletion. Okay. Next, ozone structure is also given here. Just you need to focus the structure of it, right? So these are the structures of ozone. If you want me to give the ozone structure, I can give you here. Ozone has got 3 oxygens, one central oxygen, 2 terminal oxygens. We know that each oxygen has got 6 electrons. तो इसके पास 6 इलेक्ट्रॉन्स होगा, 1 2 3 4 5 6, राइट. तो इसमें भी 2 इलेक्ट्रॉन्स होंगे, इसमें भी 2 इलेक्ट्रॉन होगा. सो लेकिन ये वाला डबल बॉन्ड है, तो इसमें 2 पेयर्स ऑफ इलेक्ट्रॉन्स आर प्रेजेंट. सो दिस ऑक्सीजन हैज़ गॉट 2 लोन पेयर्स. द वन विद द सिंगल बॉन्ड हैज़ गॉट 3 लोन पेयर्स, एंड दिस ऑक्सीजन हैज़ गॉट 1 लोन पेयर हियर. इसके पास क्या है वो चेक करेंगे, लेकिन दिस इज द स्ट्रक्चर. सो द बॉन्ड एंगल इज लाइक 118 या 113 टू या 118 के बीच में होगा. इन बिटवीन द बॉन्ड एंगल इज गोइंग टू बी इन बिटवीन दिस. तो यहाँ सो दिस इज टर्मिनल ऑक्सीजन, दिस इज सेंट्रल ऑक्सीजन, दिस इज द टर्मिनल ऑक्सीजन. इनका क्या करना है, आपको फॉर्मल चार्ज कैलकुलेट करना है. बोलिए, फर्स्ट ईयर में देखा है फॉर्मल चार्ज. हाउ कैन वी कैलकुलेट द फॉर्मल चार्ज? చెప్పండి అమ్మా, ఎవరైనా ఒక ఫార్ములా చెప్పండి ఫార్మల్ చార్జ్ క్యాలిక్యులేట్ చేయడానికి. చెప్పండి అమ్మా, ఫార్మల్ చార్జ్, హౌ డు వి క్యాలిక్యులేట్ ద ఫార్మల్ చార్జ్? అమ్మో మాట్లాడరేందమ్మా, ఆర్ యు దేర్? పేర్లు పెట్టి పిలుస్తాగండి ఇక. తేజశ్రీ, అంజలీనా, ఆర్ యు దేర్? Radha, Akshita.
Yes, sir.
Formula to calculate the formal charge. అయ్యో మర్చిపోయారామా మొత్తానికి, అసలు ఐడియా కూడా లేనట్టు ఉంది కదా. ఏ బోర్డు కనిపిస్తుందా? బాలరాజ్ సార్, కెన్ యూ సీ ద బోర్డ్?
Yes, sir.
రైట్. ఫార్మల్ ఛార్జ్ ఫార్ములా చూడమని చెప్తా. ఫార్మల్ ఛార్జ్ ఈక్వల్స్ టు వ్యాలెన్సీ ఎలక్ట్రాన్స్ మైనస్ డాట్స్ మైనస్ లైన్స్. దిస్ ఇస్ ద ఫార్మల్ ఛార్జ్. మీకు తెలిసేది ఇప్పుడు గుర్తుకొచ్చి ఉంటుంది, కానీ అది మీ ఫార్మల్ ఛార్జ్ గుర్తుపట్టడం రావట్లేదు. చెప్పండి, ఇప్పుడు విల్ ఫైండ్ హియర్ ఆక్సిజన్ 1. ऑक्सीजन के पास वैलेंस इलेक्ट्रॉन्स आर 6. हाउ मेनी डॉट्स आर देयर? 6. हाउ मेनी लाइन्स कैन यू सी? 1 ఈక్వల్స్ టు -1. సో దీని దగ్గర ఉన్నటువంటి ఫార్మల్ ఛార్జ్ ఎంత? -1. సో వాట్ అబౌట్ దిస్ వన్? యూ విల్ ట్రై ద సెకండ్ ఆక్సిజన్. సెకండ్ ఆక్సిజన్ is also 6 minus right? How many dots are there? Only there are two dots, -2. And how many lines can you see here? 3 bonds are there. Lines means bonds. This lines equivalent to bonds. So which equals to how much it is? +1. So what is the formal charge here? +1. Right? So what about here? So it is 6 minus dots. 1, 2, 3, 4 dots are there, and 2 dots are there, which adds to 0. So that means there is no formal charge. One oxygen has positive charge, negative charge, another oxygen has positive charge. So therefore they cancel out and end up with the neutral molecule. This is the ozone structure. And these two bonds are resonating bonds. So you can shift these bonds on the other sides. So 1, 2 single bond may become double bond. In that case 2, 3 bond becomes what? Single bond. So this is about the ozone structure, right? Ozone structure is here. Then we'll talk about the uses. What are the uses of it? Ozonized water is used by everybody nowadays. In every house has got ozonized water, isn't it? So the same thing here. It is used as a germicide because it's an oxidizing agent, disinfectant, for sterilizing water, right? So our water purifiers in the house, water purifier. So water purification technique में, so sterilized water is prepared. This water is also called as what? Ozonized water. So we also call it as RO pump, right? This is what you call it as RO pump. It is also used for bleaching of oils, ivory, flour, starch. It acts as an oxidizing agent in the manufacture of potassium permanganate. Right? Potassium permanganate preparation lo దీన్ని యూజ్ చేస్తాం. So this is about the ozone class. Okay. So we'll move on. The next one we have to talk about sulfur. Yeah, these two questions, can you try to answer these two questions? Why does O3 acts as powerful oxidizing agent? చెప్పండి మా ఆన్సర్ చెప్పండి.
Because it releases nascent oxygen.
Yeah, O3 is thermodynamically unstable, immediately decomposes to oxygen and releases nascent oxygen. This nascent oxygen acts like an oxidizing agent, right? Next, how is O3 estimated quantitatively? So for this you need to write two reactions. So you have to treat the ozone with potassium iodide in presence of water, where you get iodine gas and KOH is obtained. The so formed iodine reacts with sodium thiosulfate, which is also known as hypo. So where you get sodium tetrathionate, Na2S4O6 plus NaI. So this is being formed here. So from this you can use it. So this is how the ozone is being estimated. Okay. Yeah, we'll go to next, sulfur. So this part is not there in our mains, but it is there for your MSET as well as advanced. Every time I've been telling these things, you should keep memorizing it. If you attend this class with little attention, you don't have to revise these things again and again, because once you enter into January month, you become very busy. You have to write mains exam, you have to prepare for practicals, you have to do the practicals, you have to write the records, you have to attend the practical exams, you have to prepare for the theory exams, you have to write the theory exams. You will be the most busiest persons once you enter into 2026, that you don't know it now, but when you enter, this is going to happen. Even you don't get time to revise these things at all. But if you attend the class properly right now, so it would be much easier for you to revise it, right? Exactly, what exactly happening is this one, right? So in last 10 years onwards, I have been seeing this one. Every MPC students tries to attempt JEE mains in the first session of January, right? So those who successful in January session, they try to prepare for advance. That is, for very few people qualify for this. अगर JEE मेंस में फेल हो गए फर्स्ट अटेम्प्ट में, they will try for JEE mains again in the second session, just अप्रैल सेशन में ट्राई कर दें. अब सब लोगों का एवरेज चेक करके देख लीजिए, जनवरी सेशन में आपको अगर कुछ 80 परसेंटाइल आ गया, जेई अप्रैल में आने के बाद उनको 95 या एबो परसेंट आ जाएंगे. तो यहाँ से यहाँ आने के बाद थोड़ा इम्प्रूवमेंट होगा. क्यों होगा? यहाँ जो जेई मेंस एग्ज़ाम उन्हें देने के बाद उनको पता चलेगा कैसे क्वेश्चंस पूछ रहे. सारे क्वेश्चंस एनसीईआरटी से ही पूछ रहे. You don't have to read any other book for this JEE mains. NCERT ये वाला जो PDF दिया है ना, इसको प्रिंट करके आप ले लीजिए, उसके अंदर भी आप कर लीजिए. ये JEE mains ये अब ये फर्स्ट अटेम्प्ट होने के बाद you will come to know that everything is there in the NCERT. Now you will study more on NCERT. In April session you will be successful. If JEE mains score in first attempt is 90, in second attempt you will get 99%. So this is the case. And if at all, if you have not scored good in April session also, most of the students end up with EPSET, right? EPSET में उनको सक्सेसफुल हो ही जाता है. देख लीजिए, यू गॉट 3 चॉइसेस. यहाँ एक बार अटेम्प्ट किया है, यहाँ एक बार अटेम्प्ट किया है, यहाँ आप चेक इन हो गया, यू आर डन, या यहाँ हो गया, यू आर ऑल्सो डन. लेकिन ये ट्राई करने के बाद सक्सेसफुल यहाँ तो हो ही जाएंगे आप. यहाँ आने के बाद पूरा होगा. ये पूरा लास्ट जब से ये जेई मेंस आ गए ना, जब से एनटीए हैज़ टेकन अप दिस जेई मेंस, एनटीए लेने के बाद जो एग्ज़ाम चल रहे हैं वहाँ से यही पैटर्न चल रहा है. एंड आई वुड से 80% of MPC students are dependent on EPSET only, because we have a large number of engineering seats here. Very few engineering seats are there in these NITs, right? Maybe in thousands, people are in lakhs, right? So it's not possible. If you have scored good marks in JEE mains, some other student has to go for their state syllabus. That's why. So you try here, then you try to improve here. If not, this is the final destination हो जाता है. सबका होता है ये मैं नहीं बोल रहा हूँ. I wish you don't come here. I wish you will successful here itself. But this is how the pattern is happening. Okay, so you have to keep these things in the mind. Don't do any other book एक्सेप्ट एनसीईआरटी. केमिस्ट्री का तो वही है. एनसीईआरटी लाइन टू लाइन याद करना है. हाउ आई एम डूइंग नाउ, यू नो इट. यू हैव बीन वाचिंग हाउ आई एम annotating my NCERT and I doing it. Okay, now we'll see the allotropes of sulfur. Sulfur allotropic forms. Okay, the sulfur forms numerous allotropes. Allotropes means existence of same molecule in different forms. Like carbon ka, you know it. చెప్పండి, కార్బన్ కు allotropes ఏంటండి? Do you remember? 10th class లో ఉందండి.
Diamond and graphite.
Yes, diamond and graphite are the allotropes. In the same way, sulfur ko bhi ivi rendu unnai. Sulfur has got majorly 2 allotropes, alpha sulfur, beta sulfur. Just we'll read out these properties, so it will be helpful to us, right? So sulfur forms numerous allotropes, out of which yellow rhombic sulfur is known as alpha sulfur, and monoclinic sulfur is known as beta sulfur. Rhombic sulfur, monoclinic sulfur. So this rhombic is crystal lattice structure hai. Monoclinic is also crystal lattice structure. Forms are the most important. The stable form at room temperature is rhombic sulfur, which transforms to monoclinic sulfur when heated to 369 Kelvin. So what is the meaning here? Alpha sulfur can be converted to beta sulfur at 369 Kelvin. When you heat this alpha sulfur to this temperature, alpha is converted to beta. So this temperature is known as transformation temperature, heat of transformation. Next we will see the rhombic sulfur hota kaisa hai. This allotrope is yellow in color, melting point is 385 kelvins, specific gravity is 2.06. Rhombic sulfur crystals are formed on evaporation of solution of roll sulfur in carbon disulfide. It is insoluble in water, dissolves to some extent in benzene, alcohol, ether. It is readily soluble in carbon disulfide. ఇప్పుడు చెప్పండి ఒక క్వశ్చన్ అడుగుతా, rhombic sulfur దేంట్లో in which solvent dissolves more? Answer is here, carbon disulfide. It is insoluble in water, partly dissolvable in benzene, alcohol like polar organic solvents. Next, monoclinic sulfur, beta sulfur. Its melting point is 393 K, specific gravity is 1.98. It's soluble in carbon disulfide. Both are soluble in carbon disulfide. This form of sulfur so this specific gravity and all this sulfur is prepared by melting rhombic sulfur in a dish and cooling till the crust is formed. Two holes are made in the crust and the remaining liquid poured out to remove the crust. So colorless needle shaped crystals of beta sulfur are formed. Colorless needle shaped beta sulfurs are formed. It is stable at 369 Kelvin and transformation temperature is 369. Alpha beta can be converted. This temperature is known as transformation temperature. Both rhombic monoclinic sulfurs have 8 configuration. ఇది ఇంపార్టెంట్ అమ్మ, నిన్న ఒక క్వశ్చన్ వచ్చింది చూసారా? సో ఆల్ఫా అయినా బీటా అయినా AC8లోనే ఉంటుంది. S6 కూడా ఉంటుంది చూడండి. These AC8 molecules are packed to give different crystal structures. The AC8 ring in both forms is puckered అంటే ముడతలు పడిన, and has crown shape. So this is the crown shape here, and the molecular dimensions are given in the figure. Several other modifications of sulfur containing 6 to 20 sulfur atoms per ring have been synthesized in the last 2 decades. These are man-made ones. In cyclo S6, the ring adopts the chair form. This is the chair form. And molecular dimensions are shown in this one. At elevated temperature, S2 is dominant species and is paramagnetic like O2. Yes, these the points you have to remember. Where is my సో దీనిపైన క్వశ్చన్లు అడిగారమ్మా మెయిన్స్లో. యూ షుడ్ బి కేర్ఫుల్ హియర్. దీంట్లో హౌ మెనీ SS బాండ్స్ ఆర్ దేర్? SS బాండ్స్ ఆర్ హౌ మెనీ హియర్? దీంట్లో చెప్పండి, కౌంట్ చేయాలి. 1 2 3 4 5 6 7 8 SS bonds are here, right? What is the bond angle here? 107. picometers. What is the bond length? 204 picometers. Okay. So this is the SE8 structure. So it looks like a chair-like structure. What is the bond angle here? 102. So this is bit smaller than this, right? So this bond angle is 107. This is bit smaller, and this length is bigger. ఓకే, ఇక్కడ ఒక క్వశ్చన్ చెప్తా చూడండి. రీసెంట్లీ ఎంసెట్లో అడిగినటువంటి క్వశ్చన్. ఒకటి P4 ఇచ్చాడు, రెండవది SE8, మూడవది O3. ద బాండ్ యాంగిల్ ఇంక్రీజింగ్ యా డిక్రీజింగ్ ఆర్డర్ చెప్పాలమ్మా. ఇవి మూడు చూసాం మనం ఆల్రెడీ. P4 లెంత్ అమ్మా బాండ్ యాంగిల్? వాట్ ఈస్ ద బౌండ్ యాంగిల్ ఇన్ P4? మర్చిపోయారమ్మా? మీరు కావాలని మాట్లాడతలేరా? సారే మాట్లాడుకుంటాడు ఓడిపోతాడు అనుకుంటున్నారా? మాట్లాడాలమ్మా. అయ్యో, మర్చిపోయారా? P4 స్ట్రక్చర్. సో దిస్ ఇస్ ద యాంగిల్, రైట్?
Actually, 60, sir. 120 and 60, I guess. 60 degrees.
So this is the angle, is the bond angle. ये 120 है, लेकिन this is not the bond angle. This is the bond angle. రెండు బాండ్ యాంగిల్ ఇవే కదా, ఇది మధ్యలో దాటేసిపోతున్నావు ఒకటి. 60 degrees. ఇప్పుడు SE8లో చూసాం, ఎంత ఉందమ్మా ఇది? యా, యూ గాట్ SE8 107, రైట్? 107 degrees. ఓజోన్లో 1118 ఎంత ఉంటుందమ్మా? సో ఏమొస్తుంది ఇక్కడ? బాండ్ యాంగిల్ ఈజ్ స్మాలెస్ట్ ఇన్ P4, ఫాలోడ్ బై SE8, ఫాలోడ్ బై O3. ఓకే, సో దీస్ ఆర్ ద స్ట్రక్చర్స్ యూ షుడ్ రిమెంబర్. ఇంకొక పాయింట్ కూడా మెన్షన్ చేశాడు ఇక్కడ. వాట్ ఈస్ దట్ పాయింట్? సో ద పాయింట్ ఈజ్, O2 is paramagnetic. Like O2, you also have got S2. तो S2 O2 both are कैसे होना चाहिए? पैरामैग्नेटिक इन नेचर, రైట్? సో రీజన్ చేసాం, నేను దీనికి సంబంధించినటువంటి ఒక వీడియో కూడా చూసాం. ఒకసారి ఆల్ఫా బీటా సల్ఫర్స్ Yeah. So S2 के बारे में he has given some a note here. We read it. So which of the forms of sulfur show paramagnetic nature? So answer is what? SE8 shows the paramagnetic nature. The vapor state sulfur partly exists as S2, molecules of which has two unpaired electrons in antibonding pi orbitals like O2, hence it exhibits paramagnetism. Okay. Yeah, the next one, sulfur dioxide. Yeah, we'll talk about the sulfur dioxide. Can you see my board? Can you see it? ఆ క్లాస్ లేకుండే సార్ ఇప్పుడు నెక్స్ట్ మళ్ళీ మ్యాథ్స్ సార్ ఏడుకోవాలి ఇప్పుడు నెక్స్ట్ క్లాస్ నాకు కంటిన్యూస్ ఉన్నది నేను మధ్యలో అటు ఇటు పట్టుకొని తిరగలేను కదా राइट सो सल्फर डाइऑक्साइड का प्रिपरेशन भी चेक करेंगे सल्फर व्हेन बर्nt in excess oxygen the sulfur dioxide is formed sulfur reacts with oxygen and forms sulfur dioxide simple sulfur solids when this is happens sulfur dioxide is formed or another reaction iron pyrites FeS2 is known as iron pyrites. So this ore is known as iron pyrites. When combusted, so we will get sulfur dioxide gas plus iron sulfide is formed, sulfur dioxide plus iron oxide is formed, Fe2O3 is formed. So these are the two reactions mentioned here. So using these two reactions, sulfur can be prepared here. So this sulfur dioxide and sulfur dioxide both are prepared here using this method, right? So we'll see this here. Right. So preparation here, sulfur when burnt in oxygen, sulfur dioxide gas is formed. Sulfur dioxide gas is formed here. In the same way, so H2SO3 when heated, sulfur dioxide is formed. This reaction is important. When iron pyrites is oxidized, we will get sulfur dioxide gas. Properties: sulfur dioxide is colorless gas, pungent smell containing gas है, highly soluble in water. Sulfur dioxide is soluble in water whereas sulfur is insoluble in water. This thing you should know it. And it liquefies at room temperature under pressure of 2 atmospheres and boils at 263 Kelvin. Sulfur dioxide when passed through water forms a solution of sulfur acid. Sulfurous acid is formed. This simple reaction ఇక్కడ arrow గుర్తు మిస్ అయింది, రైట్. నెక్స్ట్ విల్ మూవ్ టు ద రియాక్షన్స్ ఆఫ్ ఇట్. సో it reacts readily with the sodium hydroxide forming sodium sulfide. NaOH plus SO2 gives you Na2SO3, which then reacts with more sulfur dioxide to form, so sulfur Na2SO3 reacts with this to form NaHSO3. Right, few more reactions also mentioned here. SO2 plus Cl2 gives you SO2Cl2. SO2 plus O2 gives you SO3. Just an addition reactions you can check here. Sulfur dioxide reacts with chlorine in presence of charcoal, acts as a catalyst to give sulfuryl chloride. SO2Cl2 is known as sulfuryl chloride. It oxidizes sulfur trioxide with oxygen in presence of vanadium pentoxide. So sulfur dioxide का two more oxidizing property है. When moist sulfur dioxide behaves as reducing agent, ये point आपको note करना है. Sulfur dioxide is a reducing agent. कल भी देखे थे अपन, sulfur dioxide reducing agent है, टेलुरियम ऑक्साइड इज ऑक्सीडाइजिंग एजेंट. ये यहाँ प्रूव भी कर रहा है, देख लीजिए. इसका रिएक्शन भी दिया है. आयरन के साथ सल्फर डाइऑक्साइड रिएक्ट करके, so iron is converted into iron plus 2. In the same way, the SO2 reacts with MnO4. SO2 reacts with MnO4 minus, where manganese is oxidized to Mn plus 2. These reactions we have seen like this. Do you remember? We can write these reactions like this. Right? For example, Fe plus 3 is converted to Fe plus 2. This is the first reaction, where SO2 is oxidized to SO4 minus 2. ये दोनों रिएक्शंस आप ऐड करके आप लिख सकते हो. तो इसको बैलेंस करेंगे, इधर एक 1 mole of electron required, इसको भी बैलेंस करेंगे. So you need 4H plus here, 4H2O, 4H2O not 2H2O not, 2H2O is required. Here you need 4H plus, right? So plus 2 electrons. So that means you need to multiply this by 2. So you get 2 moles of Fe plus 3. Now the electrons are get cancelled, plus SO2 plus 2H2O, which gives 2 moles of Fe plus 2 plus SO4 minus 2 plus 4H plus. So this reaction is oxidation reaction, right? Sulfur dioxide reduces Fe plus 3 into Fe में reduce कर देता है. Okay, so and the other reaction MnO4 का reaction है. MnO4 reaction we know it. MnO4 reaction, so where MnO4 is converted into MnO4 minus is converted to Mn plus 2, and SO2 is converted to SO4 minus 2. ये दोनों reactions आप balance करेंगे तो आपको balanced equation मिलेगा. This is gonna be 4H2O, here it is 8H plus and 5 electrons. This is again the same, 2 moles of H2O, 4 moles of H plus and 2 electrons. But electrons are not matching here, so this one should be multiplied by 2, this one should be multiplied by 5. So we cancel out these electrons, we'll get the final reaction. That is 2 moles of MnO4 minus plus 5 moles of SO2 plus 5 2s are 10 moles of H2O plus 8 moles of H plus gives us, కింద రాస్తా నేను, 2 moles of Mn plus 2 plus 5 moles of SO4 minus 2 plus 8 moles of H2O and 4 5s are 20 moles of H plus. So these common things you can cancel and you can write the simplest form of it. So this is how the sulfur dioxide reactions. There are 2 reactions of sulfur and 3 preparations. Okay. So we will continue the class in the evening today. Okay. Thank you. Sir.
Okay, 5 minutes. 11 o'clock, up to 11 o'clock, 5 minutes. Okay, no problem, sir.
Evan, sir? We have to continue till 11 o'clock? Okay. Uses చూద్దామమ్మా ఒక నిమిషం ఆగండి. సో సల్ఫర్ డయాక్సైడ్ యూజెస్ ఒకసారి చూద్దాం. Sulfur dioxide is used in refining petroleum and sugars, in bleaching wool, silk, and as an anti-chlor. Removal of chlorine is anti-chlor, disinfectant, and preservative. Sulfuric acid, sodium hydrogen sulfide, calcium hydrogen sulfide, industrial chemicals are manufactured from sulfur dioxide. The liquid sulfur dioxide is used as solvent to dissolve a number of organic and inorganic solvents. So these are the sulfur dioxide preparations and properties, right? So we'll take a few questions here. What happens when sulfur dioxide is passed through aqueous iron sulfate 3 solution? 3 solution is reduced to second solution. Comment on the nature of SO bond formed in SO2 molecule. Are 2 SO bonds in this molecule are equal? చెప్పండి అమ్మా, SO2లో ఇది ఒకటి So very good point here. You have one lone pair, so you got one pi bond and another pi bond. So this is the structure. Hybridization of the sulfur is sp2. The pi bond is p pi से एक बनता है, and the other one p pi d pi. So all bonds are not equal. SO bond and other SO bond are not equal because one is p pi, another is p pi d pi bond. How is the presence of SO2 is detected? The presence of SO2 is detected by passing it through iodine solution या potassium permanganate. Is it given somewhere? Okay. Okay, sir.
Okay, sir.